Okay guys, so lesson 4 is just like lesson 3, except we can use our calculator. Okay, so keep in mind that we obviously have to memorize or use exact values without a calculator for questions that any angle that has an angle of multiples of 30 degrees, so that includes 30, 60, 90, 120, etc. Okay, any multiple of 45 degrees, 45, 90, 135, etc. 60 degrees, 60, 120, which is also a multiple of 30. Okay, all of those, you know, the 90 degree, 180, the quadrantals, all of those we have to memorize. But anything else we don't memorize. So for example, the first question says, point P, -1, -8 is on the terminal arm of an angle. Find the angle. So I know X is negative and Y is negative. So of course, I'm in the third quadrant. So I'm just going to do a little crude sketch of that. We're not getting out the protractors here. It doesn't have to be perfect. So I know that that would be -1 and -8, right? This would be -1 and -8 would be down here. And of course, our terminal arm starts from the origin and moves out. There's our point. This would be my point. -1, -8, right? We've moved left 1 and we've moved down 8. Makes sense? And there's my right angle. So of course, what would be the angle? And that, I think we could fit the standard position angle, theta, is what we're looking for. So that, of course, is the angle that starts at my initial arm and ends at our terminal arm. That's theta. So before I can find theta, I want to find this little reference angle, okay, theta r. And theta r would be the opposite divided by the adjacent. So I know that I'm going to use my tan ratio. So it's the inverse tan of 8/1. Okay, and we never put in the signs because the signs just simply tell me where to draw my triangle or where to draw our terminal arms. So I don't want to put in the signs. Okay, so when I push in the inverse tan of 8, I'm just going to show you how to do that on the calculator. Okay, we'll do a couple that I show you, and then the rest I'm just going to assume that you can do this, and pause the video and try it with your own calculator. So in my calculator, let's just find my calculator. Okay, hopefully this shows up on the screen. Usually it does. I'm going to make sure that my mode is degree. So right now it's not. If you see what is bolded there, it's radian. I'm going to arrow over to degree and push enter. I am now in degree mode. So I want to do the inverse tan of 8, or 8 divided by 1. 8 or 8 divided by 1, same thing. And we get 82.87, or 82 and 9/10, I guess that would be, or if it says round to the nearest degree, that would be 83 degrees. And it looks like the custodian is cleaning my floors. So theta r would be 83 degrees. It doesn't really say where to round, but often angles are to the nearest degree. So we're just going to round to the nearest degree, okay? So that was our theta r. We want theta, so therefore theta itself will be 180 plus 83. And I should always remember to put those degree symbols. Sometimes I can get lazy about that, which is bad. So please don't do that, or I'm going to dock you marks on your test. Haha. Do as I say, not as I do. So theta would be 263 degrees. Okay, next question. Solve for theta. Round answers to the nearest tenth of a degree. Now, this one's a little bit different. So this one we have a picture right away. This next one, I don't have a picture. I don't really know much. All I know is, right, I've got some ratio. Now here's how we do this. I'm going to think about that cast rule, okay? Because I know if I'm solving for the angle, CAST, cosine is negative. Now where's cosine negative? I know cosine is going to be negative in the second and the third quadrants. So I'm going to do a little baby sketch, okay? And I'm going to draw 2 triangles in the second quadrant, okay? And in the third quadrant, okay? And so what I've got is I've got 2 little right angle triangles, and I know that cosine is negative there because x is negative there, right? Negative. So all this tells me I never put in your calculator, never put negative sign. Okay, oops, not sing, sign, oops. In calc, it just tells you Q, okay? That just tells me that it's Q 2 and 3, okay? And then the ratio, remember from Math 10, if I want to find a angle, remember from Math 10, I'm going to find my reference angle. So theta r is going to be the inverse cos of 0.6753. Inverse cos of 0.6753. So if I do that with my calculator, this is the last one I'll show you with my calc, but I would go second function cosine of 0.6753, and I get 47.48 degrees. So I know that my reference angle is 48 degrees. So that means this little angle right here is 48 degrees, and this little angle right here is 48 degrees. So if those two are 48 degrees, then I need to find what is actually theta. Theta is my initial and standard position angle. So there's one of my angles, theta, and my other angle is right here. So theta is actually 180 minus 48 degrees and 180 plus 48 degrees, which is equal to 132 degrees and 228 degrees. And I really wish you guys were with me because you could yell out those adding and subtracting. How you guys are so fast at that. Okay, let's do the next one. Sine of theta is negative 0.8090. Okay, what do we do? The first thing I do, I'm going to draw a little baby sketch. I want to think, where is sine negative? This tells me that I'm in quadrants 3 and 4, right? Sine is negative here and here. So I'm going to draw a little sketch. Okay, and again, it doesn't have to be perfect. I'm going to draw two little right angle triangles, and then I want to find, that tells me exactly where I am, and then I want to find my reference angle. So theta r is the inverse sine of 0.8090. And the inverse sine of 0.8090, that reference angle is, and I would encourage you to try this along with your calculator, is 54 degrees, 53.99, so 54 degrees. So that means, again, that this little angle here is 54 degrees, and this little angle here is 54 degrees. So of course theta would be 180 plus 54 and 360 minus 54. Theta is 180 plus 54 and 360 minus 54, which is 234 degrees and 306 degrees. Okay, there's our two angles. There's only two more questions here, so what I would strongly encourage is, why don't you do this one as a try? Okay, let's do D together, and then we'll do C as a try. So if you look at question D, this is a cosecant theta is 1.248. So what you want to do with this one is you want to change this to a primary ratio. Okay, and of course remember there's one co in every pair, so this is sine and cosecant. So secant goes with sine. So if cosecant theta is 1.248, then sine of theta will be 1 over 1.248 because it's a reciprocal, okay? And therefore you can just leave this like this. I still need to think now what, this is positive, so where am I? Okay, I have to think I'm in quadrants 1 and 2 because sine is positive in quadrants 1 and 2. I'm going to sneak a little triangle picture in there. Okay, always I draw a picture, little baby sketch. Again, we're not getting out the protractor here. We're just drawing a little sketch, and away we go. So there's my two right angles, and what's our reference angle? Theta r is the inverse sine of 1 over 1.248. I'm just going to plug that right into my calculator. My reference angle is 53 degrees. Okay, and so what are our two angles? Our two angles are in the first quadrant. So theta here is equal to our reference angle. Okay, right? Because there's our reference angle as well. And in our second quadrant, theta is 180 minus our reference angle. So therefore theta is 53 degrees and 180 minus 53. And so theta is 53 degrees and 127 degrees, if I can do that in my head. Yes. Okay. What I would do now, that's probably one of the more difficult ones on this page. I would pause the video and try question C on your own and see that you understand what we're doing. Okay, if you took the time to do that try question, you should get answers of 162 degrees and 342 degrees for your two angles in standard position. And for the assignment, I would recommend that you do odd letters for number 1. I think there's 8 questions there if you just even did maybe the odd letters, and numbers 2 to 4. Those would be excellent practice. Okay, good luck, and if you have any questions or concerns, please do not hesitate to contact me. Thank you.